Hello everyone, welcome back to this second video as part of a series of videos that the eConsult is trying to make to make you feel more comfortable with the content that is taught in the economics course at Warwick. Today we are going to explore partial derivatives and its application in macroeconomics. You should have already watched the first video where we talk about partial derivatives and the multivariable calculus. This video, you should watch it after you have completed your micro course in week 3, where you are going to explore the concept of marginal rate of substitution and marginal utility. So we're trying to link up together here the content that is taught in EC 140 mathematical techniques and the microeconomics, because these two are closely related to each other, and the tools that you learn in math techniques are going to be extremely useful in microeconomics this year and in the following years. So this is the formula that you have probably seen in week 3 of microeconomics. This is the formula for the marginal rate of substitution, and it's a derivative given by dx2 over dx1. So what does this scary and complex thing mean? This is the formula for the marginal rate of substitution, and it's a division, as we see here, between the partial derivative of the first variable over the partial derivative of the second variable. And what we are differentiating here is the utility function with respect to x1, the first variable, and the utility function with respect to the second variable, x2 here. Let me give you an example now. So this is one of the utility functions that you probably encounter when you study in microeconomics. And so what we have to do here is to find the partial derivative with respect to x1 and with respect to x2 to find the marginal rate of substitution that we are given here. So we have to find these two parts separately so that we combine together to find the marginal rate of substitution. I want to give you now the possibility to solve this by yourself, as we have done an example in the previous video. Just to remember that x1 and the x2 here are just two variables, just like x and y in the previous video. They just changed the name to x1 and x2 because we don't have like an infinite number of alphabet, but we do have an infinite number of numbers, so we can number them to infinity. So just treat them as x and y here, and try solve for the partial derivative for x1 and partial derivative here for x2. So please feel free to pause the video and give it a try. Alright, I hope you had the possibility to give this a try, and now I'm going to proceed and solve this problem. So the first part, the partial derivative with respect to x1 is just gonna be x2, because we're gonna treat x2 as a constant, just like any number, and the derivative of this is just gonna be x2. And for the similarly for the second part, it's just gonna be x1. So now let's combine these two things together with the formula here, where we asked to do the division between the partial derivative with respect to x1 over the partial derivative with respect to x2. What we get is going to be x2 over x1, which is going to be the MRS for this utility function here. The previous example was quite straightforward and easy to do. Obviously, there are like very complex concepts behind the MRS and the marginal utility, their application, and what they mean in terms of microeconomics. But we're not going into that detail because we're just trying to like apply the knowledge that you learn from EC 140 mathematical techniques to microeconomics. So we're just going to practice another example, so that you get more familiarized with this kind of application. Here we have a Cobb-Douglas function, utility function, where we have x1 to the power of alpha times by x2 to the power of beta. This is something that you encounter very frequently. Sometimes you will see this written as x1 to the power of alpha times by x2 to the power of 1 minus alpha, because what they're gonna give a condition that says that a plus beta equals to 1, and obviously if we arrange beta equals to 1 minus alpha, we can replace this to get this part. But yeah, we just keep going with this part of the function. So just like we did before, we're going to try and find the partial derivative with respect to x1 and the partial derivative with respect to x2. So feel free to pause the video and give it a try. I'll come back and solve this problem for you. So compared to the previous one, this one is going to be more complicated and tricky, so don't feel bad if you didn't manage to solve it. Now I'll go through the whole thinking process behind it. So for the first one, partial derivative with respect to x1, we're going to multiply the thing by alpha, then x1. Here we have to subtract the power by -1, so alpha minus 1. And the second part here is going to stay constant, as we said, because we're treating it just like any number, so x to beta. Maybe now try stop this video if you didn't do it correctly, and solve the second part of this question. Okay, now I'll do the second part here, and it's going to be very similar, so just beta, and then we treat this part as a constant, x1 alpha. Then here, so we multiply by beta already, and we just have to subtract the power by -1, so x2 to the power of beta minus 1. And yes, these are the two solutions to this problem. So this is it for this part of video about partial derivatives and its application to macroeconomics. I hope you enjoyed it. See you in the next video.